Hello class. In this lesson I'm going to apply what we've learned about arc lengths and the areas of sectors in order to solve geometry problems. In this example we have this three-dimensional solid, and I'd like you to try to draw a cross-section of the figure where the cross-section is taken parallel to the base. So try that and then I'll show you what my cross-section looks like. So hopefully what you have looks like two concentric circles. And this shape has a special name in mathematics called an annulus. It comes from a Latin word, it means little ring. And you might have also heard this type of eclipse called an annular eclipse. And that's because the sun looks like a little ring around the moon here. So how could we calculate the area of this annulus if we know the radius of the large circle, call it S, and the radius of the smaller circle, call it R? Well, we could take the area of the larger one and subtract the smaller one from it. And if we factor out our common factor of pi, then we end up with this formula. So how can we calculate the area of this annulus? So let's use that formula that we just discovered in the previous problem. So pi times the larger radius squared minus the inner radius squared. And we get an exact answer of 24.75 pi square units. In this example, they give us the diameters of the annulus for the larger circle and the inner circle. So what will its area be? Well, we still use the same formula as we did before, but now we have to divide those diameters by 2 in order to have the radii. And then we just plug in the numbers, and we get 10.56 pi square centimeters. So here's an algebraic application. So I'd like you to try to write an equation that describes this situation. So we don't know what the radii are, but we know the relationship and we know the area. So try that and I'll show you my equation. So hopefully you wrote an equation that looks something like this. And when we simplify this, on the inside we have that 2r squared becomes 4r minus r squared is 3r squared. And we divide both sides by pi, so we just end up with 3r squared equals 12. Divide by 3, you get r squared equals 4, and take the square root, and we get r equals 2. Now, it wants to know what the radius of the larger circle is. So the larger circle is going to have a radius of twice that, so 4 units. In this example, they give us the arc length here as 10, they give us the radius. We have to figure out what the measure of the central angle is. So try setting up an equation for this problem, and I'll show you what mine looks like. So if we're talking about degrees here, you should have an equation that looks like this. So x is the angle, and we're going to divide that by 360. So 360 degrees in the circle. And this is just the formula for the circumference. And whatever this is, this fraction of the circumference has to give us 10, because you know that's the arc length here. So now we just got to solve this for x. So we can simplify the left-hand side, and we end up with 1/15 times pi, so pi over 15, times x. And so we can multiply both sides by the reciprocal here, and we get x is 150 divided by pi. And so we round it to the nearest hundredth, and we get about 47.75 degrees. And now I want to figure out what's the area of sector CD, so the area of this sector in here. Well, let's find an exact answer. So we're going to plug in 150 over pi for x. So what equation could we write in order to figure out this? Well, the area, A, is going to equal this measurement, this amount of degrees, divided by 360 times the area of the entire circle. So pi times 12 squared. And if we simplify a little bit, over here, this fraction is to 5 over 12 pi. And this is 144 pi. So the pi's cancel out. So 5/12 times 144 gives us 60 square units. In this lesson, we learned how to solve various types of geometry problems by applying what we know about arc length and the area of sectors. Thank you for watching this video.